Morning, class. I'm going to take a little time and do all the work for section 1.5 for you. I know that we did 7 through 12 in class, but I'm going to do them again here for you, just really quick. All right, use the following function modeling the company's weekly profit in thousands of dollars in terms of their weekly commercials. First thing I want to look at is what is my independent variable, and since I have a graph, I'm going to know that it's whatever's on the x-axis, which is the weekly commercials, and then my dependent variable or my output is my profit. Okay, so what inputs make sense in the context of the problem? I could put that in there and I could say, hey, what number of weekly commercials make sense in the context of the problem? Well, since we're talking about profits, I don't want to be in the negative. So, the values below the x-axis or 0 would not be any good for me. So from 20 to 80 weekly commercials. Use a little shorthand so I can go a little bit quicker. What are all the different profits or the outputs? Well, again, we want to go from 0, and then the highest point is right here. So from 0 to 80,000. Okay. How many weekly commercials give the best profit? That means I'm looking for my maximum. My maximum is right here. The number of commercials that gives me that maximum is 50. What is the best profit for the company could expect? Again, I look at that maximum. Now I'm looking at the profit, which is $80,000. Okay, between how many weekly commercials does the company get better and better profits? When is it increasing? I can see from 20, it's on the increase all the way up to the maximum, which is 50 commercials. So from 20 to 50 weekly commercials. And finally, number 12, how many weekly commercials does a company get worse and worse? Or when does it decrease? Well, we can see at the maximum, it starts decreasing until it gets to 80. So 50 to 80 weekly commercials. So there's the ones we went over yesterday. Let's look at the next page. All right, this first section here. Use the following graph showing modeling of a man's stock market investment value in terms of V, in terms of his age. Well, if you don't know what the input and the output is, we can look down here. We can see on the x-axis, it's our age, making our investment value our output. So now let's answer the questions. If the man began investing at 20 years old and retired at 80, at which point he sold his stocks, what inputs make sense in the context of the problem? Well, you just told me he's only working from 20 to 80. So at age 20, right there, and then he sells them at age 80. So that tells me that this value over here, or this part of the graph, is non-existent. Like he hadn't even invested money. I know that the graph tells us or gives us his profit and loss and all that stuff, but if he hasn't bought it till he's 20 and he sold it when he's 80, that stuff on the outside there doesn't make any sense. So to answer this question, what inputs make sense? 20 to 80. Kind of funny because they gave us that information in the question. What are the different investment values the man had during a time? Well, here's our lowest value, which I'd say was about 25K or 25,000. And then here's our highest value, which looks to be about, we'll say 78,000. As long as you're close, and remember we can use the squiggly equal sign to represent approximate. They're approximating. Number 15, at what age was his investment the highest value? Well, here's our relative max or local maximum, and that age was 30. Ugh. He didn't do very good at his investing, did he? At age 30. At what age was his investment the lowest? Well, at age 70, it was about 25,000 at age 70. Between what ages is investment growing? Okay, so now I'm going to erase some of this so we can look again. We started at 20 and we ended at 80. So it was growing from the time he started until he got to 30. So from 20 to 30, it was growing. And then it started growing again when he was 70, from 70 to 80. When was his age's investment losing value? Well, from 30 to 70, he was losing money. That's a long time to be losing some money. 19, overall, he started investing at 20 and he retired at 80. Did he make or lose money, and how much? Well, when he started at age 20, say he had what, 65,000, and then at age 80, when he sold it, he had about 35,000. So he lost 30,000, excuse me. 65 minus 35. He lost approximately $30,000. Ouch. Don't have him invest for you. Number 20, what appears to be the earliest age he should have retired after 80 in order to at least break even? Well, here was his highest amount. Well, breaking even, I guess that would be his starting point, right? So it would have been right there. If you want to consider like his break even of his highest point, we could say over there, we could say 90, but I would say about 87 years old. Again, I'm approximating there. And to be honest with you, if you had put 90 and could explain the fact that, because that's equal to his maximum amount and that's what you consider to break even, I think I would accept that. And sometimes, as long as you can give an explanation as to why you chose what you chose, you can make it work. All right, let's look at this last one. Use the following graph showing a function modeling of the penguin population in millions in terms of average temperature at Antarctica Fahrenheit. Okay.
So here you got a new basketball player.
Yeah. And we're recording, but Zane's going to be playing for us now.
Oh, yeah.
Everybody say hello to Mr. Love. Gotcha. All right. So what inputs make sense in the context of the problem? Remember, we're talking about inputs and outputs here. So our inputs are our average temperature, and then our outputs will be the population. So what average temperature makes sense in the context of the problem? Well, we're talking about population, and the lowest population we could have would be 0. So again, the stuff below wouldn't make sense here because you can't have a negative population of penguins. So from 0 to the highest value is about 8 million. All right. So, I'm going the wrong way, aren't I? I'm looking for inputs. So I do want to look and say that those things below the X are not important, but then I need to turn around and look and say, well, from negative 100 to 20 degrees. So sorry about that. From negative 100 to 20, I need to do that too. 20 degrees makes sense for the inputs. What are all the different populations the penguins could have? Well, again, I don't want this stuff below because I can't have a negative population, so I can go from 0 to 8 million. What average temperature gives the highest penguin population? Well, here's my maximum, and the temperature that gives me that maximum is negative 40 degrees. And what is that highest population of the penguins? It's 8 million. 25, between what temperatures does the population grow? And we're starting over here at negative 100, and it's growing until it gets to negative 40. So from negative 100 to negative 40. Now, notice that I put 2 in these because there was a negative sign instead of just a dash. Not that that's hugely important, but don't allow somebody to mistake a dash for a negative sign if you're dealing with some in your intervals. So if you have an interval with negative signs, use 2 instead of just the dash that we use sometimes. Between which temperatures does the population shrink? And then we can see from the maximum all the way down to 20. So from negative 40 to 20 degrees, the population is shrinking. So hope you did good on those. And I hope this explanation was helpful. Have a great day.